Hey everyone, we'll be starting soon. The speaker will be joining us shortly. Kindly wait. The speaker will be joining us shortly. We'll be starting the session soon. Welcome everyone. The session will be starting soon and the speaker will be joining us shortly. Kindly wait. The speaker will be joining us any minute now. Greetings, everyone. As students of VIT and members of the Mozilla Firefox Club, we extend a warm welcome to everyone present. The Mozilla Firefox Club VIT presents the event Connecting the Dots, Data Science, and the Power of Knowledge Graphs. The event aims to provide a platform for sharing innovative ideas, discussing current industrial trends, and a networking with peers. Joining us as our guest speaker, having worked in the software industry for over 30 years, we have Dr. Shyam Sundaram, who currently holds the position of Chief of Business Ontology and Knowledge Engineering at Bajaj Finserv. Some of the key areas Dr. Sundaram focuses on are production scale data science and machine learning, graph models, large-scale data engineering, and building for data science and engineering. Along with Dr. Sundaram, we have Mr. Sridhar Aluru joining us as well, who is currently working as a data science engineer at Bajaj Finserv after graduating from our very own institute, VIT Vellore. A very warm welcome to both of you, sir. Together, the speakers will be giving us an insight into the world of data science and explaining its true potential. Now, I would like to hand over the floor to Dr. Sundaram to guide us in the field of data science.
Hello, hi. Am I audible to all?
Yes, sir.
Awesome, very good. I think wonderful to see. I think a pretty large audience already gathered. Uh, so we'll try to make this session quite interactive as well. So Sridhar and I, we've got a kind of a small presentation, but also what we will do is we are going to try to make it more conversational, so that you take away a lot of messages for yourself and being students. And also we'll also show you, to make it realistic, we'll have a live demo of a knowledge graph as well. And you're going to have somebody who's also part of your community. His name is Animesh. He's also been part of a couple of open source work that I do. And in fact, one of his ideas, we have kind of built a lot around it. So we'll also show you something in action. Okay, so what I will do, if it's okay, I'll start sharing up my screen. Sridhar and I will kind of talk together. Sometimes there may be confusion because he might also be excited to talk and I might also be talking, but we'll kind of work through it. We'll have a question answer session of about 15 minutes towards the end. Other than that, I think just enjoy the session and feel free to post questions, messages, whatever you need to. If there is something that we cannot get to as a part of this session, we'll try to answer it to you and send it back to the organizers as well. Okay, so I'm going to share my screen. Just a second. Okay, is my screen visible?
Yes, sir, it's visible.
Perfect. Okay, great. Sridhar, you also let me know when, in case I need to change the slides or something. And I think if Animesh, you're on the call, I would just advise you to keep the things ready. Okay, wonderful. Again, so I've just put the caption of our session. Okay, so the topic is extremely fascinating: connecting the dots, data science, and the power of knowledge graphs. So these are our GitHub links. There's also LinkedIn, but then we're also fairly technical at hand. So if you want to see what we're up to, the GitHub will give you a flavor. We're going to talk today about the following topics. I'll just kind of walk you through it, though it's easy. I think because most of you are students and you're kind of going through a lot of learning, we want to kind of talk about data science. Where is it today from a practical and a practitioner perspective? And where do we think it's going today? And again, these are perspectives that we are sharing. You may be entitled to a different view, but these are some of our thoughts and perspectives. What is happening with data science? And then in specific, what does it mean in terms of graphs and knowledge graphs? And then the hot topic of the day, everybody is talking about generative AI and then graphs and then co-pilots. Have we made it in life? Have we lost our degrees? We don't need to study anymore because an AI is going to take over all our jobs. And this big question keeps coming up to many people. Some people think, do I have to look for a different career? So we'll try to give some perspectives. And then we don't want to make it only just a pure presentation and fancy ideas. We want to show you what knowledge graph is. And then we'll leave it open for Q&A. There are some perspectives on AI as a career and all that. I've been sharing some of these on my LinkedIn, but I can also try to cover some of these things. Okay, now let's take the first one, which is data science. Where is it today and where are we going? Sridhar, you can pitch in as in when required as well. So we'll just work through it. So data science, machine learning, these are very commonplace words. Almost everyone's heard about it. Uh, Wherever you go, you find data scientists. You walk on the road, you find data scientists. You have jobs that says we are data scientists. And then, so that means this profession got created a long time back. However, has it reached a capacity like software engineering? Very fast approaching it. Now, when we talk about data science, we are generally saying it's a long journey. So it's not something that you've become an expert at, or you say that I've become an expert and that's it. It's a journey, and all of us keep learning in a continuous basis. And I think the most important element of data science is there are new algorithms, there are new techniques, there are new technical capabilities that is coming in, and there's always a need for self improvement. Okay, now there are different ways in which data science is also growing. One is both on the computer science or the algorithmic side. The second part could also be on the actual implementation of data science. And the third element is also talking about the technology, scaling, and so on. Now, one of the interesting pieces is, I mean, all of you are familiar with the Moore's law, which keeps stating that, the technology starts getting, it doesn't stagnate, the chip computing power keeps increasing and increasing, and hence, along with that, there's a lot of infrastructural developments that are happening, which means that you're able to do more computationally intensive workloads. So technology is a constantly changing factor, but what makes it more fascinating is not just the technology, the programs, the algorithms are also getting intelligent and smarter, riding on technology. What else is interesting is because the data is now getting really, really large, or we can say enormous, because we are able to capture whether it be an IoT kind of a scenario. We're getting access to lots of structured data and a lot of unstructured data, social media, emails, blogs, so on and so forth. So we just have an abundance of data that's getting generated. Now, the dire need, or why is data science so relevant and why is it very important for all of us to keep focus, is that data is just going to be enormous. But at the same time, we need to be able to solve for better outcomes. What does that mean? That means, let's say you're trying to solve problems. Some could be societal problems, some could be very specific corporate or enterprise related problems. We need to keep constantly understanding this, understand the data, understand how are we going to drive outcomes, which means if something was happening at a certain capacity or capability level, can data science, with the help of data, make it better, and hence either improve, make things much more better, make the customer or the consumer of the service a lot more better. So I think this is extremely very critical for all of you as students as you embark on this journey. Now, the other piece, which may sound trivial, is the landscape of data science, machine learning, or AI, or whatever these terminologies that we hear, is an extremely large landscape, and it keeps changing by every day, every month. Now, there is, how do you make the right choices and how do you build tangible skills? I think these are very critical elements that we have to talk about, because the way things are going, I mean, large language models, chat GPTs, llama, all of these are terms that now all of a sudden people are, it's just becoming a very commonplace word. Now, what does this mean to your career? What does this mean? I mean, is a data scientist mean all of these things? I think things are changing. There are various aspects of data science which has also become very different. One example that I would like to take, and Sridhar can also add maybe after the few words that I'm going to compute this, is in the roles that I see today when I engage with my team, or when I'm engaging with some of the other peers of mine, there's a need for people who are thinking end to end. which means you are not just simply going to be writing 5, 4, 6, 10 lines of code. You're going to be part of solutioning end to end. In software world, we call them as full stack engineers or developers. That kind of a notion is also coming into the world of data science. So maybe Sridhar, you can add a few words, then we
Yeah.
can go to the next slide as well. Yeah, go ahead.
Yeah, so I think that was very relevant. So since I'll talk with respect to the context that can be relatable to the people here, the students who are in like third year or second year. So when I was in college, the data that I used to work on was very small. I used to do some Kaggle problems. But when I shifted to the industry, at least for the first 1 year, I have realized that there's a lot of uh, skills other than just coding, other than just writing 10 lines of code or using a sophisticated model that a good data scientist should have in order to solve the problem. As Dr. Sham said, full stack data science is something that the data science teams have to adopt even at workplace. We That is very essential to build end-to-end data solutions, right from data collection to actually deploying and in fact driving business outcomes, something that business can consume. So that end-to-end journey is something that students should embark on when they shift to the industry. And that is my personal learning, which can be very relatable to the people who are getting into data science. Right? Yeah,
Okay. All right. Shall I go ahead, Sridhar?
sure. Sure.
Yeah. All right. Okay. So now, with that context, just a quick, I hope all of you are able to hear us clearly, and uh, this is just a quick thumbs up would be good, just to make sure that everyone's doing okay.
Yes, sir, we could hear.
Perfect. All right. Thank you. All right. So now let's talk about the second topic, which is what is happening with data science, and then what's the linkage, what does the graphs, knowledge graphs mean? I'm going to try, I'm keeping this at a very simplistic language level, purposefully not getting into the technology or showing you, we're not showing you any dense or heavy slides. Today, when we work with data science models, we typically take up domains. It could be finance, climate, it could be engineering, it could be any specific domain and a specific problem set that you're trying to solve for. You generally work with data, and you try to take data sets, you try to identify where these data sets are available from probably from many sources, and then you kind of bring all this data together and you try to put it into a kind of a nice table structure, which is like, rows and columns have the variable, I mean the different kinds of variables that you've considered, and then you may or may not have kind of a labeling that is done. In some cases you'll say that this is an example of a good outcome and this is of a bad outcome, or if it's, let's say, in the case of any specific tagging that you do. So typically you work with data sets, you bring it into table, then you sometimes have a tag. You have two kinds of ways to solve the problems. One is you have supervised techniques wherein you know the outcome and then you try to train it on supervised knowledge. And then the other one where you have untagged information, you look at unsupervised techniques, which are examples are like clustering, different kinds of clustering algorithms, which help you to kind of identify patterns. Now, in a logical way, these are the ways in which we work with machine learning or data science today. Now, in the case of supervised machine learning, again, it depends a lot on the kind of data, the size of the data, how did you train, making sure that this is relevant. You have different kinds of testing techniques to make sure the algorithms are working fine. And then you take a call whether this is okay for getting it deployed into production or a particular use case. And then you have a lot of complex pieces there because you have to integrate it to some system, maybe an app, maybe a web application, or some kind of an internal system to make these things work. So model development is just one part of it. Getting it deployed for consumption is the second part of it. And the third scenario you could also have is a model gets developed, and then you find that there are a lot of challenges. The model is not behaving the way it has to behave. The outcomes are not matching what is required. It's giving a lot of wrong predictions, maybe, as an example. And then it means that there has to be another part of the life cycle which says I need to go back and see, is something changed in the data? Do I need to add more aspects into my model? So there's a lot of remodel or training that may need to be done again as time goes by, or the data is manifesting different kinds of patterns. In the case of unsupervised techniques, wherein you have lots of data, but you really don't have any tagging that is being done, it also is a little tricky because you don't have a baseline, you don't know what it was, and hence you use clustering to see patterns or cohorts, or uh, similar data points clustered together, and then you try to apply domain to see whether is this really happening or not happening. And with that, you also try to build a certain kind of a construct which says, this is my assumption, this is my understanding of how this data is manifested. And so in a sense, if your clustering is done properly, you kind of get it into a tagging kind of a scenario. Now, this is harder than it sounds, but this is how some of the techniques can also be applied. Now, what happens if, let's say, when you bring something into a very linear kind of a representation, which means you are actually trying to bring everything into a row, and then the columns are the different measurements or data variables that you're trying to use. Are you missing something in that representation? Is the first question that you will have to think about. Now, what happens if I convert it into a graph? And graphs are very intuitive for us because we work and breathe with this every day. Simplest example is your social network. You're connected to somebody on Instagram or Facebook. You're either following or connected, or sometimes you're connected to a person. If you take your Facebook, you have friends in first degree, then you have people who are not connected to you over second degree. So our brain and the way we normally lead lives, we actually follow a very graph-like construct. Now, what would it mean if I have data and I was looking at the data from a relationship standpoint of view? So we'll talk a little bit more about this in the next couple of slides, but placing the idea there to say, if I were to associate value or some importance to, let's say, two people that are connected, and the way they're connected could actually come back and say they're connected maybe because they studied in the same college, or they're working in the same place, or they have certain common properties in terms of, let's say, if there are two individuals and both of them are sharing the same identifier, and let's say, for example, if both of them have the same driving license, do you think that would be okay? Logically, you'd say no, right? There should be only one person with a driving license. Two people cannot have the same driving license. Maybe there's some problem with the data. Or if you were to take a lot more case to come and say, there is a student A, and the student A is studying in, let's say, VIT, and he or she is studying in a department A. There's another person C who's also studying in VIT, but studying in a department B, a different department. Now, are both of these people connected? Technically, the answer is yes, because both of them are studying in the same institution. However, they're not connected because they're not part of the same department or stream. But the power that it comes and tells you is, if I were to layer more kinds of information, let's say, for example, the year of passing, or the year in which they're studying, or the hostel block where they're staying. Now you can, or their base location or where they come from. Now you can actually start deriving a lot of information based on the relationships that the particular person is holding as a part of this network. Now, if I were to able to create variables based on these patterns and interactions, it would probably add more value, again, business to business, use case specific, to my overall data modeling, which again implies I would be able to make my data science models more and more powerful. The other way that this information also starts playing a critical value is if you have information or you want to understand the behaviors of a particular, let's say, person in this network, the graph is probably the best mechanism for you to unravel patterns of how a particular person in this particular social network that I spoke to you about is connected across the various parts of that system. In a simpler way, level 1, level 2, level 3 connections. Are there similarities of background? Are there similarities of demographic? Are there similarities of what they studied and so on? So the whole layering of information gets a lot more intricate. How do you process it? How do you do that is a little bit more tricky and challenging. And again, use case dependent. So graph structures by and large are very intuitive, very simple. But then if you want to scale and you want to build a very large scale graph, even of a social network, it's your traditional working of a row column is not going to necessarily work. You're going to have to start looking at a graph model or a graph thinking. So graph schema or databases, they require a lot more. Some of them require a thought. And some of the areas where you need to think about are, what is going to be the schema? What is schema? Schema is nothing but a mechanism of representation. How do you represent the information that you have coming from various sources into a schema or a structure? So data schema thinking is something that you're going to have to really think about. What are the ones that, according to me, are relevant for me to keep on the graph? What are some of those things which I can take out of the graph and link back later? The second thing you want to think about is when we talk about graphs, and in a very simplistic way, if you want to talk to or understand something from a friend who is not connected to you, but you know that you have a common connection point, what do? You first talk to the person known to you to maybe ask the other person to give you an introduction so that you can ask a specific question and you probably get better support because you went through somebody you knew. So this is a very simplistic example of a traversal. So you are able to traverse a graph and then understand the linkages. And then based on the linkages, you're able to figure out and saying, okay, there is a connection and this is how the connection happens. And hence there's a potential linkage of you to engage. The second piece of the puzzle is, what if you were to ask a more complex question? Identify all the students who are in the third year of the computer science stream in VIT. Now, that's like combination of you traversing the graph, but also trying to do some computation on the graph and saying, these are the people, and then what do I do with these set of people? That's kind of your compute thinking. Now, as you build and think about it, you also start thinking about what happens in the pre-processing of the data, what actually happens on the graph, and then what actually happens post-processing. So if you keep this orientation of data is there today, how do I represent this in a graph structure, which our minds and brain does in a beautiful way. But if I were to bring it into a programmatic, algorithmic way, these are some of the thought processes that you have to kind of think about. So what we'll do right now is I'm going to let Sridhar give you an example of this in a more graphical notion. Yeah, go ahead, Sridhar.
Yeah. So I think you can go to, I think, so this is a fairly simple diagram, but I'll try to give a context on why I have put this diagram. So currently, most of the loads that are run in the industry, or even as a student, as students, what you do is you take the Excel. In the industry, most of the databases are the SQL databases. So graph is something, it's a new method of storing data, I would say, which the industry is slowly adopting. It's a different way of looking at the data. Let us say uh, a student in this chapter with the mobile number 89 is also present in one more chapter with the mobile number 89 and is also present in another club with the different characteristics. Now, if you consider this data to be in a system, currently the conventional way of storing this is a classic RDBMS database. So what do I mean by an RDBMS database? basically you'll have the columns and then you'll have the rows. You'll have the name, you'll have the mobile number. But whereas if you come to a graph is a different kind of orientation in which you're storing the values that are being present in the database, in the RDBMS, as nodes and edges. So in the relational databases, you have columns and rows. Here you'll have nodes and edges. So as you go deep into graph, it's a very interesting way of modeling the data. So what are the nodes in your graph schema? So just like how we have a column format in the RDBMS, we also have a schema. We also have something called a schema in the graph database. So uh, when we say that a company is using graph as a database, using graph as a data structure, or harnessing the power of graph, it comes down to a fundamental principle. How are they using graph as a data structure in modeling their data? So most of you might be preparing for your placements and you must be doing data structures and algorithms. So graph, you must be knowing of graph as a very important data structure. So at scale, how do we uh, build data on the graph? How do we put data onto the graph is something that is very interesting. Building graphs at scale, and uh, the many industry use cases which are built on graph. That's why they're interesting, because it's very efficient way of storing data, and also it works at scale. Yeah.
Okay, so let me go to the next point. So this is, I think, probably there's so many new buzzwords, and the latest buzzwords are generative AI and copilots. So question, everybody is talking about generative AI and everybody is talking about copilots. Have we made it? So these are, of course, viewpoints that Sridhar and I have kind of put together, and you could have your own point of view as well. So it's not that this is going to be, etched in stone. You have the points of view, but I'll try to make the points as objective as possible. I think first thing, the generative AI as a concept will definitely drive many new use cases, and it's definitely going to impact areas where there's going to be a lot of tasks which may be very uh, repeatable, where maybe this could assist, and it will assist. So basically what will happen is there'll be a human being, and because the Gen AI is very working on a very simplistic predictable tasking, it could actually make the productivity more efficient for the human being, because that can be automated and that human being can actually do more other things and probably manage the AI kind of thing. However, there are challenges. For those of you who have worked on chat GPTs and who have used some of these large language models, many a times the information that is given back is extremely incorrect, but extremely well worded and made to look like it's very realistic. And hence, one of the terminologies people use is called as hallucinations. And so, how to spot a hallucination is very hard, because if you didn't know it, you won't know that it's a hallucination. In some cases, it's easy. In some cases, it's really tough. So that means there is going to be some kind of a mechanism for a human to be able to manage AI, and there is a lot of technical modalities around this, while each of the large language models are also doing a lot of intense testing. But it's also going to be important, because it's going to start scaling, because large language models are going to be built by a number of people, and how do you know that it's been trained properly? How do you know that the outputs of this is validated? Is a really complex question. So there is going to be a need for managing this. So the second big thing that's being talked about, and particularly things like your GitHub Copilot, and Microsoft has become a big way in this, is what we call as a copilot. There will be certain classes of repetitive tasks, which means to say, write a program that will take some X input, process Y, give an output of Z, and things which are very simple and standard. The technology of AI will very fast assist you in writing that piece of code. Now, that's an example of a co-pilot. But what does that still mean? There is still a pilot. That means you are still in control of what's going to happen in how that code is going to get used or capability is going to get used. And hence, there is still going to be a human being that has to own the outcome. So that means while a lot of efficiency gains will come because of a co-pilot, there's going to be a lot of work still required to integrate, make sure that it's being used and it has an outcome that is owned. Now, I'm not sure how many of you have used ChatGPT to write a lot of code. I have experimented this quite a few in certain very specific areas, and I found a lot of challenges in the output that was given because sometimes those libraries did not exist or it was not the right answer. Now, if if you're a subject expert or know a little bit about the subject, you could catch it, but otherwise it's extremely difficult to catch it. So these classes of problems is going to be coming through, and it doesn't matter. It's not just about ChatGPT. It could be any LLM that could have this challenge. Now, there's this terminology called as XAI, which is nothing but explainability AI. Now, this is a very important piece that as you become data scientists, as you grow your career and deliver outcomes and build models, it is very important that any model that you do, there is a very clear and high quality output. And why did that output come out? There has to be something which is known as a explainable, that if this row got selected or the machine learning model or the AI gave me this response, what was the reason for me that this response came out? There has to be a very clear and transparent manifestation of this. So as you build these models, it's also important to keep in mind that these cannot be black box. The person needs to know, how did you arrive at this decision? So transparency, and also in certain cases of generative AI, and let's say you're getting a lot of generated content, you also want to know, where did this information come from? Is it hallucinated or is it coming from an authentic source? And so on. The next important part, and there are many software frameworks as well, even for machine learning. If you look at responsible AI and search out, there are lots of examples of frameworks that are available today, which give you a lot of explainability on why your classification model is behaving in a certain way. Why is your TensorFlow model behaving in a certain way? It's already available. So if you take a look at some of these libraries and frameworks, it's available. But it's important to build this into your process. And you can try this even when many of you are doing your student projects. Bring explainability and responsibility into your outputs. It'll make a world of a difference. Next one is, there's also a lot of change from regulations in India as well. The bill got passed recently, the privacy bill. So there's a lot of data, AI, privacy related regulations. There's a lot of change that's constantly happening both in India and in the world. So you got to keep paying attention to these critical changes. Okay. Many a times they're not directly responsible to you, but you're part of it because you're writing all of this code and process and components for machine learning and AI. The other big delta is Gen AI or generative AI and large language models are slightly more trickier because it's not just their traditional data science, but the people who build this have also learned how to work with extreme large amounts of data, computation, and building the technology that drives this end to end. So this is to come and tell you, and as Sridhar alluded, initially it's very interesting when you take a small problem statement, you go to any of these crowdsourced sites, download some notebooks, run some sample data. But in real worlds, in real business worlds, it's a very different skill to drive production scale outcomes. Okay. Sridhar, you want to add anything else?
No, I think you have summed up everything.
Okay, perfect. Now, to give a little bit of more flavor and interest to this, I'm going to request, I think the to give access to Animesh to quickly show an example of a live working knowledge graph, open sourced, and it's all available on my LinkedIn as well. It's a project called as PyPyVcom. So can we quickly get, yeah.
Hi, thank you, sir. I already have the access.
Yeah, okay, great. You want to?
Yeah, I'll just show. Yeah, is the screen visible?
Yeah, visible. Yes, go ahead.
Okay. So this is uh, this is our basic interface of our PyPyRecom. This is basically built on Streamlit, and this is how it is. If I search for something like time,
Can I, Animesh, can I just add a little context while you're doing
yeah,
this?
sure, sir, that
Yeah.
will be
Yeah.
sure.
So what Animesh is demonstrating here, this is a live running system. And what we're trying to explain to you is most of you are in the software or at least in data science world. And now let's say, let me give Animesh an interesting topic. Let's say we want to talk about uh, time series. Okay, time series. Yeah. So you're trying to do some kind of analysis on writing software or writing some Python work based on time series. Okay. Now, most of you are very comfortable with Python, but you want to understand which is the best library that I can use for building my time series. Now, you uh, as a software person are only interested in trying to find out quickly, very precisely, what are all the information that's available with me. So what happens in this system is what Animesh has run this. This UI is a little bit weird, but it's already identified some very key packages. We'll actually show you the actual file, then you'll have a better idea. We haven't fully cracked the visualization engine because it's a little difficult for large scale visualization, but there's a version that we're trying. Let's see if that works it. But Animesh, let's show them the JSON.
Sure, sir.
So what this does is this has done some intelligence, and the JSON will actually show you the, yeah.
I think it's stuck. I'll just reshare.
Yeah, stuff. So what happens over here is you as a software developer want to simply know what are the most critical packages that I want to work with. Now, you want to not waste too much of time doing Google search, going to Stack Overflow. These are your traditional approaches. Instead, you just want to know from a very solid source, which is your PyPy, which is your standard repository of Python libraries. You want to be able to identify what are the appropriate packages that I can use. Now, this is exactly what PyPy, that package, that system that we showed you, does. So while it looks very simplistic, it's not just a web crawler, which is simply going and crawling and getting you it's not just getting you just the crawled information. It's also putting it into a graph. And then in the graph, you're actually getting it connected. So it will come and tell you a package one linked with, let's say, called time series, linked to another package. Yeah, I think he's got it back on. Yeah. Is it back on?
I think it's on. Actually, I don't know why, but the front end is getting stuck a bit. I'm just trying
That's
to
fine.
fix it.
Can you explore any other graphs? That's fine. Take any other graphs.
Yeah,
It's not
you
a
can
problem.
actually see the data as of now, how
Yeah,
we have
just
it.
yes. So what this has done is, in a sense, what it has gone and done is it's identified some, not all. It's not just simply got everything with the name time series on it, but it's tried to get you as much information from PyPy, and it comes and tells you about each of these packages. What's the name of the package? Maybe the author name in this particular case, the development status of it, and so there are very specific uh, information that is available about each of these packages. And then you as a developer, what would happen is you would be able to very quickly choose based on the output that's given over here. You can all try this, it's available. It's on a free server, so it's not really scaled up for high performance, but it will basically have a lot of information available to you. You can also download a local version of it and build it on your local laptop so that you don't have to use this Streamlit. So you can run it locally and then experiment as well. But the intent is you're getting very, very specific outputs, which you can actually take to actually put into a requirements kind of a file for your Python package and building it. And you can also make it a little bit more stringent by saying, I'm only interested if it's greater than certain Python versions, if it's only in a development kind of a case. Okay. Udit has raised his hand. Is it for a question, Udit? Can we hold it till we finish? Yeah, just keep the question. Yeah. Okay. Just click on the contributing libraries if that opens up. Otherwise, we can go to. Yeah. Okay. Okay. Not a. Yeah, it's come. This is called Murphy's Law. When we have to present it, that's when
Correct, sir. Exactly.
it's not. All right. Not a worry. Let me go back to the deck. Then we'll come back on this. But anyway, we'll share this again out to all of you so that you can try it out. And you can do that. All right. Let me go back to sharing my
Sir,
screen.
we have the
Yeah.
contributing library, sir.
Okay,
Yeah.
it's fine. I think it's just on. This is all on a very. This is all free servers, so it's not really meant for anything. But this comes and tells you. I'll quickly show you the architecture as well. But these are all the different libraries that is there. And just to tell you that the output looked very simple and very nice and very nice and simple. But the architecture that was around this is. Yeah. Do you have it handy, or shall I show it?
Architecture.
Yeah.
So do
Or
you
shall I?
also want me to show the JSON
Yeah.
and the GML?
Yeah. If you can show the GML, would be good quickly, and then we can show the thing as well. So
Sure, sir.
when I was telling you that this is not just a web scraping, there was actually something. So we actually saved the output of the graph in what is called as a graph markup language. And sorry to show you something that looks a little scary, but if you guys are data scientists, or if you are more technically oriented, all this is in machine readable format. So you can actually take this and do any interesting post compute or post process that you want to do. If you see carefully in the output of the graph, here in this case of the node is actually a package. And in that package, you can see various attributes of the package. Currently, as a part of our data analysis and what we wanted to build, we have kind of kept it very simple. We have kind of kept some of the nodes as the packages, the license types. And if you see the license types, you'll get things like, whether it's an LGPL or AGPL or MIT license. You'll also get things like, the development status. And then we have another critical piece, which is the dependency package. Because when you choose packages in Python, you also need to ensure that your dependency packages are also linked and there is no conflict when you build packages. Okay, so this is to come and show you the technical nature of this. Can we quickly show the architecture as well?
Yeah, sure.
So the UI it's more for people to search, but the real power is you downloading the GMLs and JSONs and using it for your own kind of process. Yeah. And all this is all available on the Git. You can also very quickly install both on Linux as well as your Windows. You can have it. So the architecture is very elegantly poised in a way that it's completely decoupled. You have a user query or request that's coming through. We are typically looking at the search package, and if you go on the right hand side of the backend layer, once you put in a search, there are 2 or 3 things that are happening. Number one, it is going and checking to see, did I already have this knowledge that I had that I'm searching for? And this knowledge is either getting saved into, it can be saved in any graph database, or it can be saved in a file system as well in a graph format. But there are 2, 3 things here. One is there's a GraphDB connector, which says I can connect to any graph and graph database. And then my actual data gets stored in some actual graph database. There are many graph databases. that are available. Some are open source, some are commercial, but we have tried it on a couple of community editions of commercial databases as well. Now, as a part of this architecture, we have also introduced quite a few things in the next version, which will also talk about indexing your searches, and then so that you can actually be more efficient when you search. Because sometimes in the search string, like how we do in Google, sometimes what you're looking for does not come exactly. So we are exploring a vector database kind of approach for the search context, and as well. And then the output at the we are trying to do something called as a LLM integration. But the problem that we have with traditional LLMs is because of challenges of knowledge that is coming from them, that if there is some hallucination, we'll have a big problem. So we are actually more interested in getting data from knowledge or domain specific sources, in this particular case PyPyD. But the framework can be built, whatever you see on the right hand side can be built for catering to specific domains. And how do we do that? We have certain configurations of knowledge maps that are configured on the server. So you can take this whole framework, make a few changes on some of the configurations on the knowledge that you want to have on the right hand side, and actually construct your knowledge base, your knowledge graphs for a specific topic. The other power of this framework is every time you search, you're actually generating a knowledge graph. There is a repository of knowledge graphs that are available. So you can actually take any one of these knowledge graphs, the GML or the JSON, and then work with it or expand with it. So this is just to prove to you that when we use the word knowledge graphs, and is it all hype, is it all just vaporware, or can you do something relevant and useful? I think this architecture framework kind of proves that to you. You want me to take back control, Animesh?
Yeah, sure, sir.
Yeah. Okay. What I will do now is just to give you a flavor of. So we showed you the demo, and just to give you a demo, what we just showed you very quickly was this is what you typically do today. You search, then you go and search your different sources. But in the future, PyPyD or capability like these actually give you a graph representation with the JSON, and then you can do it. What you see on the right hand side is a real life version of what we just showed you. We package this data through a visualization engine. There are a couple of tools. There is a tool called Gephi, GEPHI, which allows you to visualize graphs. But you can also visualize these. And because since this is a knowledge graph and it's a very contained and specific graph, we are able to work with it through a visual interface. Okay, this architecture I spoke to you about. A point of view, and this is again a point of view that I've put together. There's a need for tangible endpoint for AI to add value. Most importantly, that requires is you need a tangible, interpretable knowledge. And the other important keyword is it has to be actionable. So whatever we have shown you in the last demonstration tells you that I was able to give you an output, which is interpretable knowledge based on a particular query, and you can take some action with it. And what is the action? You can include it into your requirements for your Python building, and hence the knowledge graph played a role. Now, in the process of this, you'll use many technologies and many things. Okay. I want to I can share all of this with you. I'll share this with your coordinating team. But these are some thoughts that I put together for your consumption. And these are just my own points of view, that if you want to build a career in AI, and the second part is how to identify a certain niche area in AI. And you can also follow me. I keep writing some of these things on some of the LinkedIn collaboratives, plus some articles I publish on LinkedIn, so that you can read these as well. There are quite a few articles that I've shared. So you're welcome to read these and learn more. But the first one tells you if you want to build a career in AI, you got to build a base foundation. The foundations are highly math, stats, computer science are very important if you want to get into the engineering side of the world. But if you're in the non-engineering side of the world and you want to use it, basic knowledge is still okay. But if you want to be hands-on, you need all of these. But you need to have very vast domain knowledge, which means, let's say you're working in finance, you need to understand finance. If it's engineering, you need engineering, and so on. Then you go on to working on a complete life cycle and the data life cycle, doing a lot of data exploratory analysis. You build models, you deploy the models, you integrate into production systems, and then you all keep thinking about scaling. Can I take it for 10 users, 100 users, 1,000 users, millions of users, and so on. You got to keep engaging, reading, engaging, publishing, contributing in specialized forums, specific forums, and so on. Focus on deep diving or specialization. Keep evolving, keep learning, keep going to next levels, keep expanding. Maybe if you are wanting to get into multi-domains, work on it. The second piece is how to identify a niche, because some of you may say, I want to focus, specialize. Again, first question, is it a hobby? Yes or no? If it is not a hobby, then you got to take up a very specific domain and work on specific problem statements. But if you get into that world, you got to follow deep domain experts, work end-to-end, deploy, monitor, evolve the model, and so on. In the case if it's a hobby, hobbies are still good. You can actually take up certain domains, explore it. Most of it is same, except that you take one domain and work on it, but you may not become an expert. You might try out something quickly. And then, of course, you publish, engage, and share, and again, keep evolving. So I think these are very quick points of view that we wanted to share for the conversation. Open to now any questions or anything that you would like to ask us.
So I'll start by asking the doubts from the audience's behalf.
Absolutely, please.
So we have a query from Raghav. So he's
Okay.
asking, what questions or algorithms are commonly used to construct and update knowledge graphs in the realm of data science?
Okay. So, Raghav, can you turn your camera on and maybe you can also.
Sir, we can't give
Is that?
access
Oh,
to.
okay, that's fine. So you said Raghav, right?
Yes.
The person was Raghav. Yeah. So Raghav, there are many ways. So the first thing that you have to do is there is no straight answer for you to say that is there an algorithm A or B or C. The knowledge graph, like how I had shown in the architecture, you construct a knowledge graph based on how you're going to get data coming from different sources of data. You will have to first get it into a representation form that can be stored in some way. And then you construct what your nodes and edges are. Now, the algorithms that we typically do, let's say, for example, if you're working on the graph, is you're going to be having to write certain queries by which you're able to traverse the graph. That's one approach. The other approach which you can also do is you can also do things like, let's say, link prediction kind of algorithms, which says a node A and node B have to be connected, but I want to determine this node A and node B automatically. Then you have a class of algorithms which are called as graph neural networks. Okay, so you can apply graph neural network kind of algorithms which run on the graph and they perform certain tasks such as these. Okay, and this is again not all. There are certain problems that are amenable to graph neural networks and some that are not. So I read some time back, I think your Google Maps also uses a lot of GNN for route identifications, I believe. Okay, I'm not sure if it's in production or not, but I'd seen some articles that was done there. The other piece where I have seen these classes of algorithms being applied are on research papers on various research topics, and a network of these created. And then you can actually come back and say, and these are generally in the area of what you call as link predictions. Okay, so this is a very short answer, but it's a very long and it's actually a very good question and also a little tricky question. There's lots of depth into this. So reach out to me if you're still serious about it, and I'll help you out with specific pointers. Yeah.
So, sir, can I move to the next question?
Yeah, please, let's go ahead.
So, the next question from one of our attendees, Aditya, is could you discuss the challenges and potential biases that may arise when building and using knowledge graphs for data science tasks?
Fantastic, very good question. Now, the most important thing the biases can come from is what are your sources of knowledge? The first and most important thing is the source of knowledge. So in our case, I'll quickly respond to you. In our example, we have taken a very trustworthy source of PyPy, which is your repository of all the high quality Python packages. Our assumption is that the data that is provided as a part of the metadata in PyPy is accurate. But however, when you are writing a query, let's say time series, as an example that I've shown you, let's say somebody use a word that this package can also be used for time series, but is actually not a time series package. That's an example of a false positive or a bias, because it's not a core time series package. Now, so what that means is, so if you see that architecture picture that we had, and all this is available on open source, you can go to the Git and see it. It's all fully available to you, including the schemas. Now, you have to really do a lot of NLP processing to ensure that my knowledge representation, before I load it into my knowledge graph, is made as accurate as possible. Okay. There will always be a bias. It's not that it's going to become impossible to have a bias, but you can try your level best. And hence, the hypothesis that we have is knowledge graphs have to be made very domain sensitive, and they have to always come from a trusted source. You can't just do like a random scrape of everything available on internet, even if you had computing power, because you could have potential garbage and bias. So you need to still work with trustworthy wisdom, and you also need to have some kind of a knowledge encapsulation done in a format which is, what I was trying to say is, attributable. Where did this come from? And hence I have a trust factor. Now let's say there's a PyPy is a very reputed site, and whoever asks a question, let's say you might also have your own personal repository and you put it on some server. Now I would probably give a more trustworthy factor to a PyPy because it's more established, validated, and there is some process around it. Okay.
Yes, sir. Sir, one common question we have received that is someone as a beginner wants to start learning data science. Like what resources and materials would you recommend to them?
Okay. The picture that I sent you, I think would be the most important one. I'll get this sent across to all of you. You can definitely share it with the community. See, your data science is a combination of many topics. It requires you to understand mathematics, statistics, and computer science as a foundation. But it is also very multi-domain. You understand? If I'm, let's say, working in the engineering industry, heavy engineering industry, I'll have different classes of problems. I'm working in medical industry, I have different classes of problems. I'm doing traffic management, different sets of problems. But the underlying architecture of all this is, if you come to data science and you come to machine learning, it boils down to two classes of techniques you can apply: supervised techniques, unsupervised techniques. If you go to supervised techniques, you can have techniques like classification algorithms. You can apply neural networks. You can apply support vector machines because you have tagged data. If, let's say, you are having data which is not tagged, then you have different types of clustering techniques. K-means clustering as an example. Or there could be many custom clustering algorithms that you run. So when you build your data science career, you have to have a foundation that says, I know how to deal with these kind of different data sets or data forms and problem statements. But for each problem, I have to identify, is it supervised, is it unsupervised, and so on and so forth. So it's a journey map. I can point you to some articles that may help you, guide you. There are too many articles on the net. There are fantastic courses that are available. I don't think it's just one or two. I have seen great articles put in and so on. But I'll try to see if I can give you some pointers. But there's just too many. I don't even want to say because it's all available. There are a lot of good Samaritans who do a lot of open source talks like these, and we publish it for consumption.
Yes, sir. Sir, one question that has emerged is that how can we contribute to open source data science projects like these?
Awesome. Yeah, good question. Uh, there are many ways. You have to first have a genuine passion, number one. If you have genuine passion, then your next step is what is the area of interest. So those two flowcharts that I gave you will help you. Are you getting into specialization or you want to explore? If you want to specialize, let's say you want to work only on imaging or image classification as a thing, then you have to identify the packages or projects that are very high active, high value, and which is working in the area of your choice. If you want to explore open source, that is to get a practice, there are many which are available. You can explore on GitHubs. There are a lot of projects that are available. If it's interesting, you can request the person who's managing the project and talk to them, and then do it. In our own case, I mean, we have because we want volunteers who are serious, so we also have people who are very serious in knowledge graphs, and PyPy Recom is also a project you can explore. But it's just hard work. I mean, it's not easy. So it's like you write high quality code. There is no, it's not like in corporate world where somebody is going to check, are you doing this, are you doing this? You write code, you check it in, package works, you unit test your code. So it brings a lot of rigor. So definitely a positive if you get into open source projects, but it also requires a lot of commitment.
Yes, sir. Sir, one question that I personally have is, why does hallucination or incorrect generation occur in AI?
So let's take the same example. I'm not going to talk about ChatGPT or any of those. I'll take the realistic example of our own package, which we did. And I take the same example that my model got trained on all the data that's in PyPy website. Now, I've trained it on data that I've received, but what if the data metadata that was provided in PyPy was not accurate? So I've trained my model on not perfect data. And hence, there is a very high possibility that if I were trying to write a language model, it generates some information, but it picked up some information which is not even linked to that package. So the probability is very high, and that's why there is a lot of human, uh, what do you call that, processes to come and check and see that the data that it is learnt on, is it correct or not. So it's a complex evolving field, Ojas. I don't think it's a simple answer. um, it's really hard. I mean, there are some examples last couple of days, and I listened, talk to other peers and friends and colleagues, uh, asking some of these LLMs questions. They give wrong answers. They give beautifully worded wrong answers. So, I mean, it's only if you know that it's wrong answer, you know it's wrong. But otherwise, it's so convincing, it's difficult. So there are different techniques. So it's not a straightforward thing, but it all depends on the kinds of data that it is trained on. Okay. I have only a minute. I have to run into something else. So I can probably take one last question if that's okay. And you can ask more questions to me and Sridhar, and then we can maybe try to answer back to you all as well.
Yes, sir. Only one last question that we have is, how can knowledge graphs can be used to build recommendation systems in e-commerce?
Fantastic. So it's a very powerful field and a complex field, because e-commerce, there are many SKUs. So if you can ask the person, if the person is very keen, you can reach out to me. I'll answer. I'll even give an assignment for them to try out. It's a slightly longish answer, so I'm not going to try to answer it now. But whoever asks a question, connect them up with me and Sridhar and Animesh. I'll give some specific perspectives to that person.
Yes, sir.
Sure thing, sir.
Okay. I hope this has been helpful to all of you.
Yes, sir. Distinguished guests and our esteemed speakers, as we come to the end of this enlightening session on connecting the dots, data science, and the power of knowledge graphs, I would like to extend our heartfelt appreciation to everyone who made the event possible. First and foremost, a sincere thanks to our speaker, Dr. Shyam Sundaram and Mr. Sridhar. Your insights have provided us with a deeper understanding of the fascinating world of data science and knowledge graphs. And the way you explained everything through examples made this session really interesting. Your expertise and willingness to share your knowledge has truly enriched our understanding. I would also like to extend our gratitude towards VIT and the Mozilla Firefox Club for their support in making this event a great success. As we conclude, a heartfelt thank you to all who contributed to this event's success. We look forward to such enlightening sessions in the future.
Yes.
And those of you who want to connect with Dr. Sham and Mr. Sridhar, their LinkedIn profiles have been posted in the chat. Thank you very much, sir.
Yeah. I think thanks a lot to the whole team. Very happy to be part of this. I hope we are able to make a small drop in your quest for the next journey.
Grateful
Okay.
to have you, sir.
Thank you. Bye. See you.
Thank you, sir.